Welcome to today's episode of QuaranTIME. We're so happy to have you here. Hello to everyone who is watching. In the chat, I can see that we've got people from South Carolina, Texas, Las Vegas,
Arkansas,
Indiana. Welcome. We're so happy to have you here. If it is your first time watching QuaranTIME, we have a format that we follow. We're going to start off with a little slideshow sharing some of the fantastic art submissions we had. Then we'll have a science lesson. We have an engineering challenge. We have fact or fiction and a math lesson at the end. So we're real excited to share this with you today. Do you want to add anything before we go to our slideshow?
No, I'm excited because I actually didn't see these yet. So
that's right. Math Dad has not seen any of these art submissions. And I will say real quick, we had way more art submissions than we would have time to be able to share with you. And I'm talking with the other members of our Science Mom squad. Shout out to Science Mom Krista, Emily, and Liza, who are in the chat moderating right now. And we're trying to brainstorm a better way for you guys to share your submissions with each other and for how we'll select them. But I am very excited to share these with Math Dad because he has not seen any of these yet. So I am going to share my screen with you and
application.
Ooh, nope.
No, you don't have it open?
Nope. I do have it open.
What are you trying to do? Is it a tab?
Here we go. So we will go to play, and we have some fantastic art submissions. Here we have a Lego character with crazy hair. The prompt was crazy hair.
So that's got to be Emmett, right, from the Lego movie?
I think so. Look, there's Science Mom spotting some fantastic crazy hair, and a marshmallow pairs well with chocolate and graham crackers and is on fire.
Would you consider dyeing your hair like that?
I don't know that I could pull off that in real life.
Look
but
how
it's
happy
fantastic.
she looks, though. That could be you.
We have Isaac Newton. And, or no, I think that was Johnny Appleseed, actually. It's a little tricky without the clues. And I loved the rainbow colors on this one. A female singer who was a voice judge. This one, I was not entirely sure on. You'll have to let us know in the comments.
Perry? Is it Katy Perry?
You'll have to let us know in the chat what you think. And then a science mom with fantastic hair. I love that one.
It's almost Dr. Seuss-esque.
This one had great clues. I was a president of the United States before I became president. I was a map maker, and my face is on currency. Do you know who the map maker president was?
Map maker president?
I didn't know either, but Google told me George Washington was a cartographer.
Really? Oh.
Yes. And then I loved the 3D textures that we've got in this one. Isn't that fantastic? These are great. I love that crazy hair. It was very creative. And then Dora the Explorer. Can you tell? Does that look like Dora?
That is definitely Dora. She loves to explore.
And then that is
that's Elsa.
That is Elsa. Even without clues, Math Dad got it. Fantastic drawing there. And then I love this one. Look at the little Science Mom logo on the shirt and that fantastic crazy hair. This one, the detail is incredible. So he could do a charm. So his hair turned rainbow. He has a small lightning-shaped scar on his forehead. I bet you know who it is now.
It's Harry Potter.
It is. And he drew him about 70 years older. Isn't that fantastic? Great detail.
Outstanding.
Guess who this is?
Okay, he does not know the words to this. Oh, it's Math Dad. It's me.
It is. It's Math Dad. He likes dot-to-dot puzzles. He is my friend. His name starts with a B. I thought that one was fantastic. And then here we've got a Pokemon. Do you know the name of that Pokemon?
That's a Pikachu.
Yep. Nicely done. Cat in the Hat.
Very nice.
Love this one. And miss my regular hairstyle. Isn't that cute? The little tears coming down. He teaches math. He is bald. Any guesses?
It's me. Yeah. I appreciate you guys giving me some hair.
We've got some fantastic Science Mom entries here that I liked a lot. I loved the little rainbow outfit on this person here. There's Olaf and George Washington. We had several George Washington entries that were just great. Elsa and I wasn't sure about this one until I saw that he is very tall.
Oh,
has a unique, recognizable voice.
Is this Chewbacca?
Yes, Chewbacca. Messy hair, don't care. Love that. And famous for the formula E equals MC squared.
Ooh, Einstein's never looked so lively.
An American star and a singer. This one, oh man, I think I got the guess right in Facebook, but I can't remember now.
Sings about rings and gold things. It's famous for her songs and Ponytail.
Help us out in the chat. Oh, Ariana Grande. That's who it is.
Okay, I don't know her.
This is my crazy hair. You can laugh and stare. I don't really care. I don't care because you all have crazy hair. Isn't that great?
That is.
And then this will be our last one for the first part. Someone made crazy hair in Minecraft. Isn't that fantastic?
Okay, that must have taken a while.
I thought those were great. And so now we'll stop sharing and we're back. So I hope you guys enjoyed our crazy hair slideshow. It was really, really fantastic and fun to see all the entries that came in, and we will share a few more of those in a little bit. But first, we are going to get into a science lesson today, and I'm really excited because this week we are going to be sharing chemistry with you, and chemistry is one of my favorite subjects. It's hard for me to pick my favorite science topic, but chemistry is always on the list.
I mean, we don't have a lab at our house, so, and you're not going to blow anything up, right?
No, we're not going to blow anything up.
We're not going to be starting fires, right?
There might be some fire,
oh, man.
But we'll talk about how to do fire safely.
Okay.
Yes.
Okay.
So, have you ever wondered why things are different and what things are made of? This is one of the most fundamental questions that people have had since the beginning of time. Why can you light a stick on fire, but a piece of metal does not light on fire easily? Why can you drink milk and it gives you nutrients, but if you try drinking something else, it's poisonous? Why can cows eat grass, but we can't? There's so many questions where if you just know what things are made of, then you'll have the answers and be able to figure them out. So chemistry sets out to answer that question. What is matter? What is it made of? And how can we predict how it will react? So let's kind of take a little trip back in time. And if you have the little notes, we are going to draw in models of the atom here. I'm going to bring you over to our whiteboard here, and we'll kind of talk about how our understanding of what things are made of, how it changed over time. So way back when, will you turn on one of those lights, please? Get us a little more light. Way back in ancient Greece, this was a question that philosophers had. What are things made of? And they came up with the term atomos, which means indivisible. And they said, well, everything is made of these tiny little particles. They're infinitely small. There are infinitely many of them. Therefore, something like milk would be made up of milk atoms. Something like a rock would be made up of rock atoms. And that was sort of their theory for what the world was made of. That theory sort of died down, and then in the Middle Ages, you had the idea in Europe of there being 4 elements: earth, air, water, and fire, and things were made up of different mixtures of those 4 elements. But that did not do a good job of explaining how the world around us worked. And then we had a scientific revolution, and our ideas evolved. And the way that our idea of the atom evolved is really kind of neat to see. So the first real model that we had after the Enlightenment period was the Bohr model. So this one said the atoms were...
Wait, so is this Bohr?
No, sorry. Thank you. Math Dad's there to catch my mistakes. The first model that we had was the solid sphere model. So this was with John Dalton back in the 1800s. Oh, and you can't see it because I was blocking it. And we thought at this point that atoms were indivisible, that you would have, this was the smallest particle, and it was just like a solid little sphere. So a little atom of helium would be a helium atom, and then if you had another little atom of, say, hydrogen, it would be a little smaller, but it would be just a solid little dot. So this theory did explain some things, like our elements being different, and elements are made of different atoms. That's true. But it didn't really hold up because the atom is actually not the smallest particle. And this is what we discovered with a scientist named Thomson. And he did experiments where he discovered electricity and electrons. And he discovered that electrons had a negative charge. So then our model changed to something that we call the plum pudding model, which I think is kind of a funny name. But that's because they thought, aha, atoms are like a big positively charged I don't know, little pudding. And inside you have all these electrons, which are sort of like the raisins just floating around in the plum pudding. So this was our second model. And that worked well for a little while because it is true that electrons are part of an atom and they're negatively charged. But atoms don't have a charge. So you've got to have something positive in there to cancel out that negative charge. So this held up for a little while, but there was a fantastic experiment that was done in the, look at my notes here real fast because there's a quote I want to read you that's fantastic. So Rutherford was doing an experiment where he took a sheet of gold that was very, very thin, and he was firing these particles at it. And if this model was true, then when he fired those particles, they should have just gone straight through like that. But some of the particles went bing, and ricocheted back. They went back the way they had come. And the only way that was possible is if there was a very solid, very dense something at the middle of the atom. And when Rutherford saw the results of this experiment, he said, "It was the most incredible event that has ever happened to me in my life. It was almost as incredible as if you fired a bullet at a piece of tissue paper and it came back and hit you." And here's kind of the crazy thing about atoms. Atoms are super small, but they're mostly empty space. And that seems really counterintuitive. How can they mostly be empty space? And it's because all of their mass, almost all of it, is centered in the nucleus. So you have the part of the atom that has mass and has weight is all together at the nucleus. And then you have these negatively charged electrons orbiting around. So here's our planetary model where you have electrons. And I guess I should have, here we go. We'll get rid of that circle. So you guys have probably seen little cartoons of atoms drawn like this, where you have the electrons orbiting around the outside, and you've got your nucleus in the inside. And here's our planetary model. And that did a better job of explaining things, but it didn't really predict how electrons would behave, because it turns out that the electrons that are out farther away from the atom behave very differently than the ones that are in closer. And so then the next model that we're going to talk about today was the Bohr model. And Niels Bohr said that, you know what? It doesn't explain things if the electrons are just circling around like planets orbiting a sun. There has to be certain energy levels involved. And so we had the first level with 2 little electrons, and then you had a second level with more electrons, and it went out from there. So electrons have discrete energy levels. And I know, especially for some of our younger kids, you might be thinking like, you just lost me, Science Mom, but we'll circle back and talk a little bit more about atoms. But what we're going to do first is a really cool little experiment, because this was one of the big things that helped people realize that our theory of atoms needed some help. And
so I noticed in the chat that the plum pudding model is definitely the tastiest sounding of the models.
Definitely the tastiest. Yes, I would rather eat plum pudding than planetary Bohr or solid who knows what. Now I'm going to move us over here, and we're going to do a little experiment that involves some fire. And before we do this, I think it would be good to take just a minute to talk about how to be safe when you're doing science. So Math Dad, who didn't realize that we were going to be doing something with fire and kind of made a joke about it. Math Dad, what do you think? How can you do fire safely?
Well, obviously you don't do it without parental permission, and not just permission, supervision. Get your parents in on it. Don't play with matches. Yeah, matches are cool. Yeah, with a parent. With a parent. Always with the supervision of a responsible adult. Not all adults are responsible. Hopefully you know one who is, and then you can do this safely. One of the things that helped people discover the theory of atoms and that atoms are discrete particles was the fact that if you burn iron, you end up with something heavier. And this is kind of strange, because a lot of times when you burn something, the result is lighter. So if you burn a piece of wood, you end up with ash afterwards, and the ash is very light. And the theory back in the medieval times was that if you have air, water, earth, fire, well, a stick has some of the fire element in it. And then if you burn it, you release that fire, and you're left with just, the water or the rock that made up that stick. That's how they tried to explain things. And obviously to us, that sounds like a crazy theory. But scientists saw that if you burned iron, then you ended up with something
heavier. So I'm going to show you first what happens if you burn still wool, kind of with a close-up view on this plate. And then we're going to see if we can get these scales right here to show us still wool getting heavier. Now, again, if you are ever doing anything with fire, adult supervision, and you also want to make sure that you have material on hand to put out the fire in case it gets too large. So I'm going to grab a little piece of steel wool right here. And steel wool is just made out of iron. It's steel, and it's something that people use to clean with. And if you take a piece of solid iron and try to light it, it's not going to burn. But if it's very, very small and surrounded by a lot of oxygen, it will. And the cool thing about what happens when you burn steel wool is really all you're doing is making it rust really fast. That's kind of a fun way to think about it. Like rusting is something that happens to iron on its own. It will oxidize if it's left around for a long time. And if we have this steel wool, which is very, very thin, and we take a match to it and light it, that will happen a lot faster. Now, if I'm going to light the steel wool, obviously I'm not just going to be holding with my fingers, because anytime you're doing fire, you want to make sure that you are safe. So we're going to set it on a little plate. And then I lost my matches. But Math Dad's got my matches. Would you do the honors, Math Dad?
You're going to let me play with matches?
I am,
All right.
because you are a responsible adult.
Because you're here to supervise me?
Yes, and I am here to supervise.
All right.
Now, I know that with the white background and the way that our web camera works, it looks like that was a little hard to see. Yeah, the white background's a little tricky. But it's a really cool thing to see in person, because there are these tiny, tiny little just sparks going along, and then it's a different color when we're done. But the thing is, when we take iron and it's very light, and it's not going to be hot at all because it's very small filaments that burn. When we take iron and we burn it, we form iron oxide. And what happens is that oxygen from the air is now bound to the iron, and that's why it's heavier. So let's see now if we can get our little scale experiment to work. This is the next thing that we're going to do.
Sorry, lift it all the way over to here. Right.
All right.
Give them a close-up view.
We'll try to give you a close-up view.
Now I've got to say, this stuff doesn't weigh very much. Is the scale would you even detect a difference?
We hope so. We're gonna find out. We're gonna find out if we can see it on the scale. And if we don't, I will put a link to a YouTube video where they definitely did see a difference. You guys ready for this? Whoa.
Oh.
I struck the match and it fell on the floor, but don't worry, we're good.
All right, they can see that this time.
All right, is it working? Is our thing of iron over on this side getting heavier? All right, from my point of view, it definitely looks like this one is going down lower, but it's fairly subtle because this iron wool is this steel wool is not very heavy. So I don't know how noticeable it is. And then your position, your point of view from the webcam is actually up a little bit higher. So tell me in the chat if you think that Science Mom is just making this up, or if you think that the steel wool is really getting heavier now that it's oxidizing, now that it's burning. What do you think, Math Dad? Can you see it? Can you see it? The scale's tipping?
Oh, I can see that it tipped a little bit.
It definitely tipped some. Now, again, it's super important to be safe when you're doing fire. And one thing to keep in mind anytime you're doing an experiment with fire is that the amount of wind you have makes a huge difference. So if you're doing this outside and it's windy, you can see that if I blow, I don't want to tip the scales too much, but if you blow, you'll see that the amount of burning that you have increases. Anytime that there is wind and fire together, you want to be extra careful, because that can often make your fire burn a lot hotter because it will give extra oxygen. And now our reaction is pretty much done. And if let's lift this up just a little bit higher so that we're parallel. It's so subtle and this scale is so sensitive, it's kind of hard to tell. But this one right here definitely is just a little bit lower than this one over here. all because that iron absorbed oxygen. It bound to oxygen and formed iron oxide.
And so where did you get steel wool? Is this something you can just get at the store?
It is. Steel wool is something that you can find at the store. And let's come over to the whiteboard now and talk just a little bit more about what happened. And Matt said, will you open up our door real quick and get a little fresh air in here?
Yep.
Because it doesn't smell very good when iron burns. Let me get my marker, and here we have, so you guys have probably seen a periodic table before, and we'll be talking more about the periodic table in next week's lesson, but iron is an element, and Fe is how that's the abbreviation for iron. And when iron is by itself, just bonded to other iron molecules, it's pretty stable. It will stay like that for a while, but oxygen, and here we have O for oxygen. Oxygen is very reactive. And so if you have plain iron and then oxygen is around, they will bond together and you get iron oxide. Iron oxide. And iron oxide, because you have the combination of iron and oxygen together, it is heavier than iron. And this experiment that we just did was actually a really instrumental part. It was a really important part of Earth scientists figuring out the idea of how atoms worked, because they realized, hey, if you can take iron and burn it and it gets heavier, it has to be pulling something out of the air. There has to be something from the air that's bonding with it. And this was a good experiment helping scientists to discover oxygen. Now, the last little part of my science lesson about chemistry, we're going to use a Sharpie and a plate, and I'm going to write on it, and then we're going to look at how differently, don't worry, Math Dad, I'm going to show them how you can get it off.
These are our nice plates, so let's just...
These are our nice plates, and you can hear Math Dad's like, oh no, you're writing on my plate with the Sharpie? Well, watch what happens.
You can eat on this one from now on.
So I'm going to write, hi, Math Dad. I'm going to write, hi, Math Dad, on this plate. And I apologize, since we are just using our web camera, I know that sometimes it's hard to see, but here is our little message on the plate. Since it's with a Sharpie, Math Dad's like, oh no, the plate's ruined. We can't get it off. And it's true that if we just use water, it's not going to come off. I can drip water across the top and nothing will happen. But if we use some rubbing alcohol, we undo that cap for me. If we use rubbing alcohol, then it's going to be very, very different. And here's the thing about chemistry that's so cool. Chemistry allows us to answer mysteries. Rubbing alcohol and water look pretty similar. They look about the same. They're both clear liquids. Of course, the rubbing alcohol smells different, but they look similar. But if we have chemistry, we can understand why this happens. Because if I wash this plate in water, even if I put it in the dishwasher, that hi, Math Dad is going to stay there. But watch what happens if we put just a little bit of rubbing alcohol on it. And I'm going to grab some tissue paper and put it at the bottom so that I don't spill rubbing alcohol all over our floor. So here we go. I've got my tissue paper here so that when I squirt the rubbing alcohol on, it won't go down. And now I'm just going to dribble it across the top. This would not have happened with water. This is a permanent marker. But with rubbing alcohol, it came right off. With rubbing alcohol, it came right off. And that's because rubbing alcohol is not the same as water. It is different. It has a different chemical. Has different chemistry. And we'll get back to that in just a minute. But first, we are going to do fact or fiction.
Uh-oh. I was supposed to double check these, right?
You were. So it's Math Dad's job to double check the fact or fiction. We take turns. And I'm going to pull up our little fact or fiction.
All right, fact or fiction. Dang. Okay, I checked 3 out of 4 of these.
So we're going to be relying on the people who are watching live in the chat to help us on these fact or fiction.
All right, and actually, I'm going to ask the one I didn't know first, so that you can rescue us in the chat. Fact or fiction? The moon is roughly a quarter the size of the Earth.
Ooh, fact or fiction? The moon is roughly a quarter the size of the Earth. So ideally, this is something that we would double check, right? We just math it out. So the Earth has a diameter of this, the moon has a diameter of this, and we would check it. I'm going to go ahead and say fact, because I'm seeing lots of people in the chat saying that it is true.
Okay, I think I've heard this before, but I honestly didn't know what it meant. So here's the problem. Mathematically, is it that the diameter is 1/4 of the Earth's diameter? Or is it the cross-sectional area is 1/4 of the Earth's cross-sectional area? Because that's what you often care about in like an eclipse. Or is it that the actual volume is 1/4 of the Earth's volume? So those are three different questions. At most, one of them is actually accurate. And I don't know, when I hear the moon is 1/4 the size of the Earth, I actually don't know which of those three they would be referring to, or if it's even a true fact at all. So
that's thinking like a mathematician.
So I mean, since 2 out of the 3 answers have to be wrong, maybe
we can just go with whichever one is closest.
Yeah, but I think I've heard that before, and I don't know. Is anybody in the chat?
Well, most people are saying true.
They think they say it's fact. Okay, I still don't know which one of those versions is the fact, but okay. The diameter. I'm seeing somebody say that. So the diameter is 1/4 of Earth's diameter. I think that one sounds the most plausible, because otherwise, volume-wise, the moon would be exerting an awful lot of pull on the Earth, and so it'd still be the moon rotating around the Earth, but the Earth would be doing maybe some rotating around the moon as well. So the diameter interpretation makes sense. Okay, thank you, chat. That's why I keep them around. All right, the U.S. has more public libraries than McDonald's.
Ooh, the United States has more public libraries than McDonald's?
Yeah.
I have to say, I sure hope that's true. That would be awesome. But I'm thinking about, okay, like where we live in a fairly small town, we have both a McDonald's and a public library that's 1-to-1. Las Vegas, which is not too far away, probably has like 50 McDonald's, and I know it doesn't have 50 public libraries. But like the Carnegie Foundation did such a good job of like putting libraries in so many little small rural locations that don't have McDonald's. I'm gonna say true. I really hope it's true.
It is true.
Awesome. Yes. Go libraries.
Yeah, I mean, who knows? If McDonald's keeps growing, it might overtake the libraries, but this is actually...
That's awesome.
Still true. Yeah, I like that. Okay. Fact or fiction? A person cannot taste food unless it is mixed with saliva.
Oh, wow. I'm going to modify that one to say someone cannot taste food unless their tongue is wet.
Fair enough.
And then it's true, because the way that taste works, like you actually have receptors and then molecules bind, and there's signals that are sent. So it has to be a wet solution for that to work. If it's completely dry, I don't think you'd be able to get the contact you would need. That's what I'm going to say.
True. You're right.
Awesome.
All right. True or false? It is impossible to hum while your nose is plugged.
I can still make a sound, but not for very long. So how long do you have to hum for it to count as a hum? Because listen to this.
Yeah, that's just swallowing.
So you can't hum when your nose is plugged. I want you to try it. You should try it.
Yeah. So no, I was cheating.
How are you cheating?
Well, I wasn't plugging it very well, but
I don't know how well that sound comes through on
I've got a little bit of room in my mouth, shove some air into, and let it vibrate there. So that's a hum is vibration patterns. Yeah, so
we've got
that was better than I did last night.
We've got several people in the chat saying, I did it, and other people saying, I can't do it. So I think everyone right now is plugging their nose and giving it a try. Can you hum with your nose plugged? The answer is not for very long.
And not very well.
No.
Yeah. So I mean, yeah, most people would define humming as making a sound with your mouth closed. And yeah, so if air doesn't have anywhere to move, you won't get much vibration. So I guess I was making a little bit of sound just by leaving a pocket where I could kind of blow the air up into my mouth, but it couldn't last very long, and certainly was not the prettiest of tones.
Not the prettiest.
Yep.
All right, before we finish our science demo, there's one more thing I want to show you, and this is pretty amazing. So you have to have a dry erase marker for this, and I'm going to compare our dry erase marker and our Sharpie. So I'm going to draw a little, let's see, what should I draw? I think I'll draw a little heart here with our dry erase marker. So I've got a little heart on my plate with the dry erase marker, and then I'm going to draw a little heart with our Sharpie over on the other side. And you guys saw that if I put rubbing alcohol on the plate, that I could get the Sharpie to wash off. Well, let me blow on this to make sure it's dry. And then we are going to pour, we're going to pour just a little bit of water on the plate, and I want you to watch what happens. So here goes our little bit of water. And you kind of need to give it a little bit of a shake. Oh, I was too ambitious. My heart was too big and I didn't wait long enough for it to dry. Do you guys see how it broke apart? I have a broken heart.
They're there, babe. They're there.
This is so cool. We've got to try one more time. And I have to say, the thing about doing this live, I'm kind of glad that you guys have the opportunity to see us make mistakes, because this is a part of life. It doesn't always work the first time you try. Sometimes you make mistakes, and that is part of science and part of learning. A little bit more to dry that off. And in my mind, that's one of the big advantages of doing it live, is that we're not able to go and edit out the mistakes. If we make a mistake, it's just here for you all to see, and it's like, whoops, keep on going, because that's what we do when we make mistakes. We keep on going, or we try again. Okay, I gotta make sure it's completely dry.
I mean, well, sometimes we give up too. Giving up's not a bad option when you've decided to try something that doesn't work. So
this is true. Sometimes giving up is a good idea. It all depends. All right, I'm gonna make some smaller dots this time, because I think I was a little ambitious with the really big heart that I did. And we'll do a little ring as well, because if the ring worked, that would be awesome. Okay, now a dry erase marker is different than a Sharpie. And the reason why Sharpies are permanent markers is because the ink does not dissolve in water. The ink is not water-based at all. With a dry erase marker, this ink here isn't water-based either, but it's very different than our Sharpie marker. Our Sharpie marker will dissolve in rubbing alcohol and will not dissolve in water. But the dry erase has enough silicone in it that it will actually float in water. So I poured a little water in here, and now you can see that my little dots are lifting up from the base and starting to move around. And sometimes they lift up right away. Other times, like these three that are here, you can see are a little stubborn. They're not lifting up. You just need to kind of give them a little bit more of a shake, and usually you can get them up, or if they're being really stubborn, you can kind of nudge them with your finger and be like, come on, come off the surface. Oh, that one's just not having it though. That one's stuck.
It's okay, 50% of them worked. Oh, there you go.
There we go. Finally came. So now we've got 4 out of 6 floating around, and they're floating around because the dry erase marker has some silicone in it, and that silicone is attracted to the other dry erase marker material well enough that they stay together. And they don't mix with water, so they'll float. Pretty amazing, right? Had you ever seen this one before?
No, it's witchcraft.
It's not witchcraft, it's science. It's chemistry. And then the last thing that I'm going to show you guys before we finish our science lesson and go on to our next activity is a bit of a mystery. So I have to say, I really enjoyed how Math Dad gave you guys some math challenge problems with the Minecraft math, and then you would have a chance to work on it and research it, and then we'd come back the next time and answer it. So I'm going to show you something with rubbing alcohol that is really, really cool, and then tomorrow we'll explain why. So here, I'm putting some water on this plate again. Whoop, Math Dad's signaling me that I don't have it up high enough. And then I'm going to drop some rubbing alcohol in it. But this rubbing alcohol I colored green so you'd be able to see it better. And this is something I'd encourage you to do at home if you have rubbing alcohol at home, but I know that can be difficult to find nowadays. So if you don't have it, don't worry. But take a look at the crazy swirling pattern that happens when we first mix the rubbing alcohol. And I don't think I have enough. Do you guys see how?
It's not dark enough.
Oh, no. So there's actually a spot around the heart that doesn't. This is so tricky, you guys, to be using a laptop camera. Okay. So the plate is covered in water now. And if I drop rubbing alcohol in the middle, it will actually create a bare spot in the middle. And then these crazy patterns. Do you see how they're moving? And how it looks all just kind of weird and crazy. There's all this motion around the edges. And then where our heart is, it actually is kind of flat and the water's not there. And again, I apologize. I know this is not showing up super well on the camera, but with the filming with our laptop, we're just doing the best we can. And then after a while, that little hole gets smaller and smaller, and then the water comes in again. If we do it one more time, you see all that crazy motion?
I don't know if they can see it or not.
I'll try and get a better video and maybe post it to Facebook. This is our chemistry mystery. And like I said, we will explain why that happens next time. So chemistry mystery, if you take just a little bit of rubbing alcohol, drop it on a plate of water, it makes all the water go out and there's a little bare spot in the middle. And then around the edges, you see this motion that is just crazy going back and forth. So
okay, this one might be witchcraft.
It's not witchcraft, it's chemistry, and it's really awesome. And I want you to kind of experiment with it, see if you can find out why, and then I'll give you the answer tomorrow. Now it's time for our engineering challenge, and there are a lot of requests for singing in the chat, but I bet they want you to sing something different.
Oh, of course, yeah.
Yes, something different.
All right,
so
we'll do a
tell us
song
the
today.
different song you want Math Dad to sing, because he does have an outstanding voice.
Oh. Wait, we're working together today, right?
We are.
Okay.
And I'm gonna set this view down a little lower so you can see better. And
all right, so here's my new song for today. You ready?
New song, Baby Shark.
Right.
We have a request for Baby Shark.
All right, here we go. I'm singing a song, I don't know the words. I don't know the words to this song. I'm singing it loud and I'm singing it long, but I don't know the words to this song. No, I don't know the words to this song.
That was not Baby Shark.
Oh, no, that's like the fourth verse. You haven't heard enough Baby Shark, but that's what it eventually turns into.
Oh, all right. Our engineering challenge today is to build a cube from a single piece of paper. So Math Dad and I both have identical papers here, and we're going to see who can build the better cube.
And we can cut it, right?
Yep.
Okay.
We can use scissors and we can use duct tape, and we're going to try and build a cube. What you laughing at?
Nothing. Okay.
Now, I will say that there are a lot of nice, if you just look up online, make a cube from a piece of paper or fold a cube, you can print out templates, and there are a lot of templates online. But just for fun, today while we do our challenge, Math Dad and I are going to try to do this kind of freehand and see what we can come up with.
So this one actually is a competition.
Oh, it is?
Right? Well, we're doing it independently, right?
Yeah, we are.
Okay. Well, I think I would fail spectacularly, except you said we could use tape, right?
Yes, we can use tape.
Okay, so with tape, this sounds plausible. Should be theoretically doable. But yeah, not an easy task. Gotta say, I'm really impressed. People who are good at origami and basic folding things, because I am not.
So I folded mine into equal segments.
Yep. Doing the exact same thing. I think we have the same plan.
We have the same plan.
Yeah.
So
Standard.
now it's just a race. Who's fastest, right?
What? Oh. Race. Okay, getting the size right from a piece of paper is the hard part. So that's why we were folding it first, because then we were able to guarantee that the pieces are roughly the right size. It's not.
All right, so I have my shape here now that has 1, 2, 3, 4, 5, 6 segments. Although it would have been nice if I had another little thing here so that I could fold it in, because those little flaps sort of help. But clearly, I am winning. Everyone say, "Yay, science mom!"
Sometimes you gotta let other people win just so they feel better. It's for their self-esteem.
We should tell the story about our first jobs. First paying job you had. What was it?
All right, the first paying job I had. So I grew up working on my grandpa's farm, and so we had about 80 cows, and so I first started off just with the job of feeding the calves every day, making sure they had some good hay to eat, and I was in charge of watering the horse and just a few odd jobs here and there, and then slowly over time that expanded, and then I started milking cows, started changing pipe. So back east, they don't have to actually water things. Things will just grow in the fields. But
out in the west, irrigation's a big deal.
Indeed.
Yeah.
So I have spent many a summer day just moving pipe, and then eventually got to drive the farm equipment, and which was kind of fun, kind of scary too. The bale wagon was crazy. You're driving around the field picking up bales with this arm. It brings them up to one level, puts them up to yet another level. You stand that one up, and then ultimately you have to stand the entire stack up. So yeah. But for the most part, I was the one who would milk the cows because I was the most patient.
Ta-da!
Oh, but I was already done. I was just making improvements while I waited for you.
You should tell them what was your great pay rate on the farm?
Oh,
How
yeah.
much did you get paid?
So I got paid like $1 an hour when I was a kid. So I earned my first $2,000 working at $1 an hour.
Yep, $1 an hour. Everyone clap for Math Dad. That's good work ethic there.
That's not how you get rich, but
nope.
I definitely learned to work hard. So, all right.
Our cubes are done. So we made a cube out of a piece of paper, but now here is the bonus challenge, is to make an infinity cube. Where's our little set of dice? Do you have it?
Yeah, I put it in my pocket. Okay.
So if you guys have not seen infinity cubes before, they're really cool. We'll come a little closer so you can appreciate the awesomeness of this. We took 8 dice and taped them together, and you can see that it's rows of 6 and rows of 1. But the way we taped them, you can fold them over and over and over, and now the 6s are all on one side and the 1s are all on the other side. And if we fold them over, we can go back to the way they were before. Whoops. Get there eventually. Anyway, affinity cubes are really fun and really cool to make. And we're going to see if Math Dad and I can put together these 8 colorful cubes that we made last night and make an infinity cube. That's our challenge.
Now, I've got to say, we watched a YouTube video, and so I was carefully just rewinding over and over again, trying to figure out how they did this with the dice. And so this is going to be a joint effort. We're going to see if together we can figure it out.
We can do it without messing up. So we'll give ourselves 3 minutes, and if we can't do it, then we will give up, and we'll post the link to the YouTube video. I'll ask Science Mom Krista, maybe, and Science Mom Liza if they can do that. What was the video called? How to fold an infinity cube out of paper, I think. It had like 7 million views, so it shouldn't be too hard to find.
Oops. Okay.
And we will be showing more crazy hair pictures as soon as we finish our engineering challenge.
All right, wait. Good.
Oh.
We don't have masking tape. That stuff's so tough.
That stuff is duct tape's awesome though.
It is awesome.
We might be out. You're gonna use that tape instead?
This masking tape.
Okay.
Yeah.
So then if we make mistakes, we can take it off?
Yeah, there's no coming back.
I see you. I hear you.
Put tape on paper like that. All right. So one thing I know for sure is that if you tape this side, you've got to turn it over and tape the opposite side.
All right. Sounds good.
Okay. So I'm going to try the same thing here.
Fold.
Okay, so now.
All right, so now we've got. Are we gonna do that with all of them?
Try to put it back. No. So you've got to do things differently here.
We've only got 2 minutes.
This isn't going to work in 2 minutes. Okay, so what do we want to have happen? We want it to fold that way.
Well, so I think.
No, but we want that.
I think we should. We want. All right, look, we've got these two folded, like taped together here, and then we've got.
So I think we need these two sides. Oh, are you using the actual model? Oh, I thought that was off limits.
Oh, they can be off limits. We'll just stick that over there and struggle.
Okay. All right. Well, if you tape one side, you always tape the other side.
All right.
Okay. No. Okay, we'll try it.
We'll try it.
It's just going for symmetry here.
All right. Symmetry is good.
Yeah.
So my first paying job, I had 2 of them actually, because my dad, when I graduated from high school, I had never had an actual wage paying job. And he sat me down and said, if you don't earn half the money that it takes to go to college, you won't be going. And I was terrified. I was like, what? I've already been accepted to a college and I'm planning on going, and half the like the total cost of like the tuition and room and board and everything was quite a bit. And so I did the math and quickly realized I don't need to get 1 job. I need to get 2 jobs. So I did. I worked for the Forest Service on a trail crew Monday through Friday. And then each Saturday.
Wait, what's a trail crew?
Oh, so a trail crew. It was the best job ever. I got paid to hike. I got paid to hike every single day, to carry a chainsaw and like cut out trees that had fallen across the trail, and to build trail improvements like turnpikes and small like little log bridges and things. Oh my gosh, best job ever. So I got a job, 1 job, yeah, Monday through Friday. I worked on the trail crew and hiked. And then Saturday and Sunday, I worked in a nursing home as a nurse's assistant, a CNA. And that was a crazy, crazy busy summer for me, because I was working every single day pretty much all summer long. And then towards the end of the summer, I went to my dad and said, here's what I have in my bank account. It's close to half, but not quite. Sorry, I didn't make it. And he was really surprised that I was worried. He was like, oh, Jenny, we just wanted to make sure that you knew how to work and that you had a good work ethic, but of course we'll help you go to college. And I was like, man. It was a good experience though. Oh, look, we did it. It worked.
Yeah, can't see the colors we tried to add very well, but yeah, I think we succeeded until I poked a hole in that one.
You did totally poke a hole in that one.
Yeah. These cubes were tough to make. Took a long time cutting them out. I keep wanting to fold it the direction it doesn't go.
Awesome. So see if you can make an infinity cube. And if you do make an infinity cube out of paper, feel free to post it on social media, Facebook or Instagram, and tag us. We would love to see your creative work. And these are really quite fun to play with. They're kind of, I don't know, they sort of have that like Rubik's Cube quality of just being really fun to twist and turn.
That's right. There are always 2 directions you can take it. And yeah.
Awesome.
Tons of fun.
Well, I'd say go us, but that was mostly you. I just did the tape. Give me 5.
You know, the tape wasn't going to tear itself.
That's right. And now, before we go on to our jokes and our math lesson, we will share some more pictures, because we absolutely loved the crazy hair photos that you got. And again, Math Dad has not seen these, so I'm going to have Math Dad come over here real quick and we'll share the screen and we'll pull back up our slideshow here. We left off with the fantastic Minecraft hairdo. And next, can you guess who that is? Look, the Total Warrior champ. The play button.
It's me.
And that one, you've got like math symbols at the edge of the hair. Isn't that fantastic?
My hair before it fell out used to look exactly like that.
I'm sure it did.
How did they know?
Here we've got Eminem and Rihanna. I love the crazy hair here and the posters. Awesome job.
Whoa!
Isn't that fantastic? Incredible coloring. I love the coloring, and I love like all the science in the hair, like the flasks and the light bulb and weather and patterns. I love the colors on this one with the stars here. Isn't that fun? And then we have, and I'm going to ask Matt if he knows who this one is. He has an adorable yellow companion, and he wants to be the best Pokemon trainer ever.
So it's Pikachu's buddy. I don't know his name. I
didn't either. I had to ask one of our kids, but our kids knew it, and it was like, oh, of course, it's Ash.
Ash. Well, that's what I was going to say, but yeah.
40 years of hair growing. The hair is very long.
I used to deliver letters. I was the 16th president, and I have black hair. So the 16th president I do know was Abraham Lincoln, and I definitely see the nice beard there. Can you imagine Lincoln with tons of hair?
Oh, it's hilarious.
Just waving it from side to side as he gives his Gettysburg Address.
This person drew their sister, and I love the crazy hair, like the green and watermelon kind of colors together. Give that cloud a friend. Who do you think that is?
Is that Bob Ross?
Yeah, Bob Ross.
That's awesome.
Oh, whoops. And we already saw this one.
But it's good enough to show again. That's a good one.
Definitely. And then this is a cat. A cat with crazy hair. Fantastic.
All right. She has a queen for a sister. She looks for her sister up the North Mountain. Is this somebody I'm supposed to know? Oh, wait. Actually, I do know this. It's Anna. Elsa. Anna.
Yes. Good job.
Once upon a time, there was a girl who has a beautiful hair. Then she found a woman inside the museum, and that beautiful hair girl is the one who painted this drawing.
Isn't the energy and the colors of that hair fantastic? I love that one. This one I recognized just from the face before I even read the clues. And
okay, Shake It Off. She thinks she can shake it off. It's Taylor Swift.
Yeah. Isn't that a great drawing?
Indeed. Math Dad! I love hair. I have hair, yeah. They're making my dreams come true.
They are. And look, here are two more Math Dad portraits that I just thought were fantastic. And we've got the song down here, singing a song that he doesn't know the words to. This one, isn't that great? It's a creeper. And their dream came true because they have hair now. And then here's another little portrait of the two of us. I thought this one was so fun. And they gave you longer hair than me.
Yeah.
And three friends always helping to keep order in the comments. Shout out to Science Mom, Emily, Krista, and Liza. Einstein. Isn't that fantastic with the violin and the piano? Those are not easy things to draw.
That's how he fits so much in his brain, is he was using his hair to store some of the extra.
Everything.
Yeah.
That's right. And then this one with the Charlie Brown and the pie. And then Yum, I love 314159. Isn't that great?
Yep.
And then here's a little portrait of the two of us. Love the crazy hair we've got going on this one.
I got a few hairs there. Yep.
And this is our last one. This one was a self-portrait, and I thought it was fantastic. Isn't that great?
Love it.
All right. And now we will come back. And we're back. Ooh, we have a request for you to sing Old Town Road. Do you know Old Town Road?
No. I actually don't know Old Town Road.
We'll have to look it up.
I think it goes something like this. I'm singing a song.
No.
I don't know the words. I don't know the words to this song. I'm singing it loud and I'm singing it long, but I don't know the words to this song. No, I don't know the words to this song.
It's gonna be in my head all day now, all day.
I think that was it. Yeah.
That was most definitely not it. So we are coming up on an hour. We're going to have our guess. Can you guess the answer? And then we're going to build a math tower and have like a more simple math activity before we go on to the real Math Dad lesson. We decided to put Math Dad's lesson at the end because it is geared just a little bit older, a little bit more challenging and more fun and interesting than some kids can handle.
It won't be so inaccessible.
Yes. It'll be similar to what it is before.
Tic-tac-toe first.
Yeah, so we're gonna do our riddle, and then we're gonna build our math tower and do tic-tac-toe, and then we'll have the real math dad lesson. So
just making sure my comments are nice and visible here. Okay.
All right. So here is the riddle. This one I did not put in a bag because it doesn't quite work to put in a bag, but it's such a good riddle.
Okay.
We're doing it anyway. So I can be cracked.
A nut. No, wait, that would fit in the bag.
I can be made.
Be cracked. Is it a code?
Nope, that's a good guess. I can be told.
Crack a story.
I can be played. I can be cracked. I can be made. I can be told. I can be played. What am I?
You're a good rhyme. That's what you are. I like that rhythm. But
some people in the comments are getting it.
Egg?
Nope, not an egg.
Egg.
I can be cracked. I can be made. I can be told. I can be played.
A lie.
Oh, I saw it again in the comments, but it's going real fast.
Code, a joke?
Yes, a joke. Because you can crack a joke, you can make a joke, you can be told a joke, and you can also play a joke. That's a good one, isn't it?
That's really good. And I see why that would not fit in the bag.
Nope, would not fit in the bag. I'm going to assemble our blocks. If you have ever wondered, what are these blocks that Science Mom and Math Dad are using all the time? You're about to find out. So, Math Dad, I'll let you.
Here, I'm going to. Are we just doing it on the floor here?
Sure.
That's probably the easiest setup. All right, so moving the camera way back.
So math starts out, we're going to build a math tower. Math starts out with counting. You have to be able to count before you can do anything else. So we're going to put our counting block right here. And then once you know how to count, you need to understand inequalities. What numbers are bigger, what numbers are smaller. And once you understand inequalities, you need to understand place value, which is hiding from me over here. Here we go. And now, when I put place value here, I'm going to show you what happens to a lot of people, especially in like first, second grade, because they don't actually understand place value, and then they start trying to learn how to add and subtract. So Math Dad, I'm going to have you come over here. Math Dad is going to try to build adding and subtracting, our next block on top of this, but because we don't understand place value, it's like this block is shaking. So go ahead and try and put that on there. Try again. No, that's cheating.
Is there some sort of metaphor here?
There is. If you don't understand place value, that makes learning how to add and subtract almost impossible. It's like trying to build on top of a block that is always moving and shaking and tipping. And the only way to get place value strong is to practice. And if you practice, then place value gets strong. And now...
So with place value, you're talking about like knowing your ones, your tens, your hundreds, your thousands?
Yeah, your ones, your tens, and your hundreds. You need to know what the values mean in a number. So if I say the number 103, how many tens are there? 0 tens. That's what the 0 stands for. How many 100s? 100. How many ones are there? 3. You need to understand that to be able to build higher. And now we are going to build our tower real fast. It's going to get even taller than me. And then we're going to do a fun little activity where we knock it down. So here we go. Once you know how to add and subtract, then you can multiply and divide, which is like adding and subtracting, but only faster. You can represent numbers with pictures using graphs. You can break numbers apart into smaller pieces with fractions. You can make numbers get really big really fast by using exponents, which is like an awesome way to multiply. You can study shapes and angles with geometry and trigonometry. And I don't know if we're going to be able to fit the whole tower on the screen. Do you want to try and push that back just a little bit more? There we go. Algebra, nice view of underneath the table. And some of these you have to do in order. Like you have to understand place value before you can really learn how to add and subtract or multiply. But others you don't have to do in order. Algebra is way up here, but a kindergartner can do algebra. If you ask someone who's in kindergarten, 1 plus my secret number equals 5. 1 plus my secret number equals 5. Even the very little kids who are watching right now, I bet you can figure this out. Just think, what is the secret number? What do you have to add to 1 to get 5? And if you're typing the answer 4 in the chat, you are absolutely correct, and you just did algebra. Now, each of these numbers, each of these blocks, you have to have to be able to put on our next block. And you can tell it's my favorite because I got all the rainbow duct tape. And in my opinion, and I think Math Dad agrees with me, this is where math starts to get really fun. Wouldn't you say?
Oh, definitely.
So here I'm going to do a little drum roll and say calculus and statistics. Put this on top. Now our tower is officially taller than me. And this, calculus and statistics, is the key to science. If you have that math, then you can do any type of awesome science that you want to do. But most people quit before they get to calculus. It's really kind of a sad thing, right? And you should scoot over so people can see you because you're blocked.
Yep.
Why do people quit math before it gets fun? What do you think?
I think a lot of them just decide, oh, I'm not good at it. And they quit before they put in the effort to get good.
I think that does happen. I also think that there are people who get shaky blocks and then they don't go back and fix them. And if you don't fix them, that's going to make your whole tower collapse. So let's pretend like...
Well, we kind of talked about that on our very first day about the importance of practicing, because it's like reading a book where you had to sound out every single word carefully.
It's super hard, yeah.
Yeah, I mean, everybody's got to start somewhere, but if you never got any better and you always had to sound out every word, I think you'd have an awfully hard time learning to love math or love reading. And the same thing works with math.
So in this little make-believe example right here, we're going to pretend like Science Mom does not like math. Everyone could say, oh, because that would be really sad if I didn't like math. And we're also going to pretend like I never practice. I don't ever do homework. I don't ever play math games. I don't ever try and get better at math. And because of that, this addition and subtraction block gets so weak and shaky that I really don't understand how to add and subtract. And so in real life, if this was my tower of math knowledge, here's what it would be like if I didn't know how to add and subtract. Everything would come crashing down. So throughout, and can you put one of those back on this shelf here so that we can have our laptop up higher? So throughout our QuaranTIME series, we will be doing some fun math games and ways to help you guys get that practice in, but also have it be fun and engaging. Because if you can get up to calculus and statistics, you have that block real fast. Oh my gosh, we maybe have a few highlights in later episodes where we can tell you why math gets so fun and amazing here. It gets really incredible here, but arithmetic, I'll be honest, I like math, but if you told me you wanted me to just do addition problems for 2 hours, I'd be kind of disappointed because it's doing the same thing over and over again. Math is so much more than that. And now it's time for some tic-tac-toe math.
That's right. Well, and most games that involve logic and thinking, even like chess or say tic-tac-toe, I mean, you're using a lot of the same skills you would need to use in math. So math is all about logical conclusions and how you can reach them. So we're gonna talk about tic-tac-toe for a minute here. My guess is that every single viewer has played before. And simple, putting X's and O's on here, players take turns, and if you can get 3 in a row along either the diagonal or a row or a column, you win. Okay. Now the question I have for you is, where is the best place to go for your very first move? If you get to lay an X down, where would you want to go? And turns out, well, there's not a great answer to that question, because no matter what, if both players play their best, the game of tic-tac-toe will end in a draw. Neither player will win. However, there are some choices that are better than others in that they're more likely to lead to a win. And just wanted to just talk strategy for just a minute on this. So a lot of people like to start in the center. And yeah, so that's a good first move. It's solid. And then comes the question, what should the second player play? Where should they play? They can either pick one of the corners or they can pick one of the edges. And it turns out already right here, if they make the wrong choice, the second player will not win. Or sorry, they will lose. So let me tell you what you do not want to do. You don't want to place your second move along an edge if the first move is on the center. So this is what you do not want to do. And let me just demonstrate how X could win here. So now X will go, maybe say here, there are multiple ways of winning. Now O is forced to go upper left. Okay, but now X can go here, and it created two different winning threats. Could win either by going at the bottom left or in the top middle, and O can't do anything about it. So in the game of tic-tac-toe, if they start in the center, you have to move in a corner. And this game is actually simple enough that you can analyze all of it. You can go through each of the individual cases and decide, okay, what are the good moves? What should we do? What shouldn't we do? But basically, the first player has the advantage. That the only way they can lose is if they're just not paying attention. But the second player is trying to force a draw. The second player doesn't have any chance to win usually, but they can often force a draw. So let me just bring up one other case. So if you start in the corner, then typically the second player will choose the center. And there are lots of options, lots of ways that this could go, and we definitely don't have time to try to analyze it exhaustively here. Although at home, if you want to play around with this, it's totally doable. And if you look on the Science Mom channel, we actually did a video on this at one point. Okay, so here's an interesting choice. What if I play on the opposite side? So it looks, well, why would you do that? And so it just seems kind of silly. But if O makes the mistake of picking a corner themselves, then X can block and create two threats at the same time. So if you look online and try to read what's the best strategy with tic-tac-toe, what you will find is that the most commonly suggested strategy is actually don't start in the center, because a lot of people know how to counter that. Instead, start in a corner, because your opponent might not be ready or might not be expecting that move and might not know how to counter it. So this week, I'm going to go through some tic-tac-toe variations and try to have some fun along the way. But this type of logical thinking is the type of thing you have to use when you get further along in math, when you're trying to prove things and where you're trying to figure out, all right, where did my assumptions take me? All right, so I want to talk about fractions for a minute. So with fractions, often we're thinking of, okay, here is one whole circle, one whole pizza, and then we can break it into pieces. So how many pieces are there here? There are 4. So my fraction that is represented by this pizza is going to have a 4 in the denominator, because the number of pieces was 4. The number in the numerator, the top number, will be the number of pieces that we shade. So here I just shaded 1 piece, so I got 1 piece out of 4. So notationally, we write 1 divided by 4. That's the same as saying that there's exactly 1 piece out of 4 that are shaded. And of course, we could chop this into a lot of different shapes and do the same thing. We don't need to make this a circle either. Circles are kind of nice because it's maybe easy to see what fraction is shaded, but I keep losing my eraser. It's actually just up on the board here. All right, but
when you get to a good pausing point, I've got a couple questions from fans to answer. Just letting you know.
Okay. Let me just draw this here. All right, so I'm going to draw a little line segment here, go from 0 up to 1, and I want to talk about how do we find a fraction on the number line. Usually we draw the number line sideways, but I drew it vertically today. So how do I find where a fraction is on here? And the answer is I slice this thing up just like I would slice a pizza. So if I wanted to write a fraction, say I wanted to know the number 2/3, what I need to do is I need to chop this into 3 equal pieces. So I'm just kind of eyeballing it here, but 1, 2, 3 pieces. So this number here would be 1/3. This, too small to even see, 1 divided by 3. This number here is 2 divided by 3. And this number at the top is 3 divided by 3, also known as the number 1. And it's important for us to be able to visualize what a fraction is and where it is on the number line. And so I'm not listing things out as decimals here with 0.333 or anything, but I'm just writing out where the fraction is. And if we can visualize this, then our intuition can come into play and can help us out with these calculations. So I realize this might not be the most fun math you've ever seen, but I bring it up for a reason. This is an important skill to have.
Math Dad made it fun. He spent all day Saturday making this little ninja activity in Desmos he's going to show you soon. I had to just say that real fast because he had a lot of fun making this.
That's right. So we are going to get to that. But
spoiler alert.
Yeah, but we should be able to do that same trick for any fraction. So suppose I wanted to get, 2/5. So in that case, I would need to chop this into 5 equal pieces. Uh-oh. Move my 1 up higher.
There you go.
2, 3, 4, 5. All right, so here would be the number 1/5. Here's the number 2/5. Here's 3/5. And here's 4/5. And here's 5/5, which is the same. 5 divided by 5 is the same as 1. So this fraction bar here, it does mean divide, but it also means the 1 part out of 5. So we want to be able to break up our number line and locate values on it. And we are going to do an activity on that, but I think Science Mom has a few questions that need some answering.
I do. So first one, we had several people asking about Desmos because we did some fun Desmos activities, and they wanted to know, if they're a teacher, can they get access to the teacher dashboard so they can do it with their class? And they also wanted to know if it was possible, because on the last one you showed how you could see the graph of like where everybody was. Mm-hmm. Is it possible for them to see that view?
So yes, it absolutely is possible. So you just go to teacher.desmos.com and you can create an activity. And there are dozens that are already built. I was going to put a link to the teacher activity online.
We will update the Patreon post for last week's one. I'll put in the link there as soon as we're done with our live stream. We'll do that.
Yep. So you can build your own activities. There's some coding involved if you wanted to do something fancy, but there are some really nice components that are already there, and that dashboard is there. Last time we had like 800 people join, and it turns out the teacher dashboard really slowed down at that point.
It did, but it sounded like it worked well for you guys, and that's really what we care about. Is if we have 800 people on and you guys are all having it work well, then we're good, and we don't mind if our teacher dashboard is slow.
And actually, what I've tossed up here is the code for today's activity. So if you want to go to student.desmos.com and enter that code, you can join the activity that we're going to try.
I'm gonna answer a few more questions while we have, and let's just leave the code up there, and that way it'll give you guys time to hop over if you want to hop over. You certainly don't have to. You can hop over later if you want. But we had a few great questions come in over the weekend on our Facebook post where we asked for questions. So one was, Tyler asked, can you turn regular ice into dry ice? How would you turn regular ice into dry ice? And the short answer is you can't, because regular ice is made out of water, and water is H2O. So you have this molecule, 1 oxygen, 2 hydrogens. That's what makes up regular water. And dry ice is made out of CO2. And so you have 1 carbon, and I'm going to sort of go like that to indicate that that's a carbon, and 2 oxygens, that's carbon dioxide. So they're actually made out of different atoms. Excuse me.
So these two here are the same atom as this big one here.
Yes. So, but we have 2 oxygens here instead of 1 oxygen. So if you wanted to make water into carbon dioxide, and all you had was water to begin with, it would be the most complex, nearly impossible process, and it would involve nuclear fission, and I don't even think it would be possible, because you'd have to be changing elements. You'd have to change oxygens into carbons. You'd have to somehow change hydrogens into oxygens, and we're talking like you would need supernovas to do this. That is what you would need to be able to convert water into carbon dioxide. So you cannot make regular ice into dry ice. That was a great question. And then another question that we had was, would Mars's atmosphere thicken if we polluted it to allow humans to live there? So in an episode last week, I said that we can't live on Mars because the atmosphere is too thin. There's actually not enough air for us to breathe. And also the amount of air that we have is not right, because there's a lot more carbon dioxide on Mars and not nearly enough oxygen. But what if we went to Mars? So here's Mars, and here's the very thin atmosphere that it has right now, not drawn to scale at all. Let's say we went there and we built a bunch of little factories to put extra air into the atmosphere, and we made it bigger. At best, it would be a temporary fix, and we're assuming that we're polluting it with lots of oxygen and nitrogen, because if we just add more carbon dioxide, that's going to make it worse for us to breathe. But if we did add a whole bunch of oxygen and nitrogen and make the air thicker, that would work for a while. But the reason why Mars has such a thin atmosphere is because it doesn't have a magnetic field. It doesn't have this core that's spinning on the inside and making a magnetic field. And that means that the sun is blasting away bits of Mars's atmosphere. And so if we did add more air and make Mars have this nice big atmosphere, after a while, a lot of it would get blown away into space, and then we'd be back to having a thin atmosphere again. Now, how long it would take, I would have to research. I mean, you could definitely have several generations of people living on Mars if you were able to do that, but there is no place like planet Earth. And then last question, how does an astronaut survive in space? Very carefully. If you are an astronaut in space, you need to make sure that you have a breathing suit that provides air for you and protects you from radiation, because space is a pretty dangerous place. And now I'll turn it back over to Math Dad.
So somebody was just asking, what state of matter is an atom?
Oh, I love that question. What state of matter is an atom? 1 is the loneliest number. 1 is the loneliest number. I think if you just have one atom, I don't think you have a state of matter. I'll have to, you know what? Sometimes you get questions that are so good, you just have to think about them for a while. That's one I'm going to have to think about.
Because the state has to do with how the molecules are bonding with each other.
Yeah.
And if there's only one atom.
If there's only one, does it even have a state? I don't know.
Yeah, you guys ask
That's a great question.
Good questions, yeah. All right. So I am going to attempt to share my screen here. See if I can pull this off. All right, so what you should be seeing here is my activity. I'm not going to get into my teacher dashboard. I see 77 students have joined. I want to just show you what I had created. So that code was 9V374S. All right, so spent all day on Saturday building this thing. I don't know if you guys recognize this guy. That's Samurai Jack. And we have a target. So Samurai Jack is being attacked by these ninja lines, and he's got to strike with precision. So 7 parts out of 9. So if I chop this into 9 equal pieces and then went up 7 of them, where would I end up? So then Samurai Jack has to swing and make his best guess. Ooh, and I was off by 0.01. Okay, next, 2/3. Ooh, right on target. 3/5. Oh, too high. 5/7. Too low. 4/8. Ooh, that's like a half. Got it. And I'm slowly losing hit points here. If I swing way off, oh no, I lost a lot of hit points on that one. So got this game. You can only play it once, unfortunately. The program I'm building this in, Desmos, is pretty darn cool, but often it's like working in a spreadsheet. You just can't. If you tried to program things in a spreadsheet, it's not a great way of resetting things. So.
And Math Dad was trying to see if there was a way to get it to be like you survived and went on to the next level, but you just keep playing until it goes all the way down to 0, and it's just, you have bragging rights with how many fraction ninjas you dispatch.
That's right. Well, I mean, you can keep playing. Your just hit points are gone. So, yep. So I managed to dispatch 12 fraction ninjas there before I died. So there's a good target for you. See how many fraction ninjas you can take out. So I had a lot of fun making that. And I actually think it would be a really good problem for kids of just about any age. You get up to 3rd, 4th grade when you actually start talking about fractions, and then this activity is for you. All right, the next one I want to talk about is, we can jump back to here. All right.
Yep. Are you going into the bigger math lesson now? Because I wanted to do jokes before we did that.
Oh, well, I was starting to get in there. So, okay, so let's do some jokes.
I will say we put out a little survey on Patreon asking how long do you want our QuaranTIME show to be? An hour, hour and a half, 2 hours, and the results were really pretty split down the middle. But I know that for some kids, sitting for 2 hours is too long, and so we decided that at the hour and a half mark, which we're coming up to, we'll share our jokes before we go into the math lesson that Math Dad has that maybe is just for a little bit higher level. And then, if you're a younger kid and you're just itching to go and build an infinity cube, you can take off and know that you're not going to miss pictures or jokes. So I'm going to pull up our jokes real fast. Math Dad has not seen these. We'll see how well he does guessing the answer. So first joke: how does the man in the moon cut his hair?
How does the man in the moon cut his hair? He uses sun scissors. He uses light.
He clips it.
He clips it.
He clips it. And the next one: what building has the most stories in any city?
I know this one. It is the library.
It is the library. Good job. Next joke: how do you fix a cracked pumpkin?
You jack up the lantern and work on it. I don't know.
That's creative. Jack up the lantern and work on it with a pumpkin batch.
Ah, very nice.
2 more. What kind of award did the dentist get?
What kind of award did the dentist get? A tooth award. A tooth fairy.
A little plaque.
Gums.
And then last joke: what do you call an alligator in a vest?
A crock-a-walk.
An investigator.
Oh, very nice.
We've started to get some really fun submissions from you guys. So if you have a joke that you make up and you'd like us to share, send it to us, because we've had
this riddle style.
Yeah, the riddle style jokes. We've had some great ones come in. And now, if hour and a half is your jam, you're ready to go off and build and have a great time. We'll see you tomorrow. And if you are ready for an awesome math lesson, I'm going to turn it over to Math Dad.
For the most part, we're going to go as long as we have good content. Each day, we won't try to target it too much, but
2 hours is our goal.
But yeah. Okay. So here's today's question. So in today's question, we have, so it was framed, what do you call it? An immortal hippopotamus.
Yes.
An immortal hippopotamus. It walks.
So when Serge wrote the question, he said a man walks, on forever. And then he said, well, but that doesn't really work because, like the man's not immortal. And I was like, why are you using man? Like, why not something fun like a hippo? And
she just wants to see me try to draw a hippopotamus.
Yes. So now he gets to try to draw an immortal hippopotamus. Good luck.
She's not supposed to be in art class, but that's okay. I'm pretty sure you won't learn anything useful here.
I like it already.
I don't know what's supposed to happen with that face.
You just need a big round body and 4 little legs.
Oh man.
There you go. It's a hippo.
An immortal hippo. Okay. So why did this hippo have to be immortal? Well, because in this problem, on day number 1, he walks 8 kilometers. On day number 2, only walks half as far, 4 kilometers. On day number 3, then we're down to 2 kilometers, then 1 kilometer, half a kilometer the next day, 1/4. So I keep cutting the distance in half. But this is an immortal hippopotamus who's going to do this forever and ever and ever. So my question for you is, how far does this hippopotamus walk total? And that's the question. I'm not even going to talk about it further today. Tomorrow I'll be back with an answer. We'll talk about how one can add up infinitely many numbers in a sequence like this. Pretty cool. So, of course, you guys should work on this at home and see if you can come up with the answer yourself. All right, so I want to tell you about a fun game called Mastermind. So Mastermind is this game. Typically, it's played with little pegs, and one person is the gamekeeper trying to. One's the guesser, and one of them is the person who knows the answer. So Science Mom, maybe I can get you to come over here and be my assistant. All right, and we're going to go, we're actually going to guess bottom to top. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Am I off the top of the
Barely
screen?
fit it.
All right, and so we're actually going to play this with numbers because I don't have enough colors to do it.
But and do you have this in the decimal activity that they're doing today?
I do have this in the decimal activity, and maybe we'll try it there once as well. But I have a secret number that I wrote down. All right.
Are you going to show them?
Yeah, I'll go ahead.
Okay.
No, actually, I'm not going to show them to the end.
Okay.
Because all right, so I want to go ahead and write it to your guess to the right here. So what she's going to do there. This is a 4-digit number, but it only consists of digits from 1 to 6.
So my first guess is 2222.
All right. So did she get any of them right? And the answer is, I'm just going to write none.
None. So I know that it has no 2s. Next, I'm going to guess 3, 3, 4, 4 to see if it has a 3 or a 4.
Okay. So now, where's my red marker?
Right there.
Oh, okay. So I'm going to give her. Whoa.
Oh, that was.
Oh, because I was unplugging the light.
Yep.
Okay.
Matt, I was kneeling on the cord.
Right. So I'm going to give you a red dot, and that means that you have one correct number, but not in the correct location.
Place. Ooh, and I really want to find out if it's the 3 or the 4 that is the correct one. So I'm going to write 4, 4, 4, 4 for my next guess, which maybe not. It might not be the best strategy, but we're going with it.
Yeah, and I think you can tell she only gets 10 guesses, and she needs to try to figure out all 4 numbers. All right, I'm going to say none.
Okay, so I know I have 1, 3, and no 4s and no 2s, and we're doing numbers 1 through 4. Is that right?
1 through 6.
1 through 6. Oh man. Okay. 1, 1, 5, 5.
Okay. So in this case, you got 2 correct things. I'm not telling you which ones, but you know that 2 of them are exactly right.
I know 2 of these are in the exact right place they need to be, but I don't know if it's the 1, 1 that's correct or the 5, 5 that's correct. So I'm going to guess 1, 1 because I know that I have, what do I know so far? I know that I have 1, 3 somewhere, and then I either have a 1 and a 1, or a 1 and a 5, or a 5 and a 5. That's what I know. But
you know a little more than that because you know where the 1s might be or where the 3 might be as well.
True.
There are only a couple of places you've narrowed it down.
That's right. The 3 has to be in one of these 2 spots. So I'm going to guess 1, 1, 6, 3. I'm going to guess 1, 1, 6, 3. We'll see what I get.
All right. I'm going to say you got 2 right. Exactly right again.
2 exactly right again.
And 1 is the right thing, wrong location.
Okay. So I'm going to guess that my 3 is one of the ones that's, well, boy, but I don't know that for sure. All right. Real fast, just for fun, because I want to know if the 6 matters. We're going to do 6, 6, 6, 6.
All right.
I'm going to rule that out.
You got one exactly right.
Okay, so I know that this third one is a 6. And I'm going to go 1. And I think that 3 has to be there too, because I know the 3 has to be in one of those 2 spots. But one of my 1s is in the wrong. Whoa, I'm confused about this right here. 1, 2, 3, 4, 5, 6. 1, 5, 6, 3.
Okay. So
we're just kind of guessing now because I don't feel like I have time
2 that are exactly right, and 2 that
yes, we're getting close.
are the wrong location.
All right, 1, 5, 6, 3. 5, 1, 6, 3.
Okay. So now you've got 1 that's exactly right.
Oh no, I'm getting worse.
And
3 that are in the wrong location?
That's right.
Okay, so wait, how can I have 1 that was right when 2 of my numbers were the same?
No. Oh no, I'm right. You're wrong.
What? 1, 5, 6, 3. 2 are right and 2 are wrong, and then 5, 1, 6, 3. 1's right and 3 are wrong.
You moved an answer that was right into the wrong spot. That's.
All right. We're just gonna guess 1, 5. 1, 6, 5. 1, 6, 5, 3. That's my guess. That's my final guess.
All right, and that's 4 out of 4. You got it.
Phew.
Guess number 9. So she was getting
barely.
close.
I got it barely.
Yep. So what? Yeah, what you will see here, if you continue on in this activity, which screen am I even using? That one. Is that I have created a similar game here where you're going to enter numbers. So this is also a game you can only play once. You'd have to log in again. But yeah, so if I type in 1122, ooh, got 2 of them right. I don't know which 2, but
hold on, sorry. There was reports of no sound. I just wanted to make sure we weren't muted. We're not muted. Say yes in the chat if you can hear us. We're getting reports of no sound. Can you hear us?
Yeah, I think they must from some of these comments. Yeah.
Okay, good.
All right. Okay, so my next guess, let's keep the 1, 1 and go with the 3, 3. Oh. Okay, I still don't know if the 1, 1 was right. Let's try 4, 4. I think the 1, 1 was the right one. Let's try 4, 5.
Oh my goodness.
4 guesses.
Did you cheat? That's really fast.
I did not. It'll pick a random one every time.
You got lucky.
I did get pretty lucky there. So, but by all means, give this a try. But the cool thing is, you get with a partner. You can get a piece of paper. You don't have to go out and purchase the actual physical game. And it's a really good logic puzzle. It'll get you thinking about, what do I know? And what am I just assuming? And sometimes you think, I've got it. Like, so Science Mom was sure, the 6 had to go right there. And it really confused her when the 6 didn't go there. But she had just assumed that it would go there. Yep. All right. And then the last thing I wanted to show.
Go back there to.
Is this one on?
I think right there. That's the one you want.
Add to stream.
Yeah.
So on this one, I had a puzzle that I'd left in the last video, and we didn't actually get to it because there were so many people and things kind of froze up on the teacher dashboard. But the question was to cut that figure into 2 pieces of the same size and shape. So when I got into the dashboard, what I saw was that there were lots of people who did manage to find the solution, but I wanted to share what that solution was. So this is an old Sam Lloyd problem. So I'm going to, oops. Thought I had the straight line tool. There we go. Like that.
Wait, what?
So
you can flip them and rotate them.
Yep,
That's really cool.
2 identical shapes there. And actually, Science Mom, you solved this one. This was one of our early Math Dad versus Science Mom challenges.
It looks familiar, but it's been a while.
Yep. And yeah, it gets cut into 2 identical pieces, but they were put together in such a way that it's kind of hard to recognize them. So kudos to those of you who took the time to try to figure that out. These dissection problems can be a lot of fun. And this is certainly not the last one you will see from me. All right. And we're back.
Okay. I am going to give a little bit of a hint to the rubbing alcohol and water mystery that we have at the beginning. Unless did you have anything else for the math?
Go ahead.
I'm going to give you guys a little bit of hint, and then it looks like we'll have some time for questions and answers. So we'll take as many questions as we can from the chat and see if we can answer your science and math questions. One question that I saw in the chat earlier was, why does rubbing alcohol smell so bad? And to answer that, it helps if we look at what rubbing alcohol actually is, if we look at the chemistry. So like we said before, water is H2O. You have 1 oxygen, and I'll draw an oxygen here in blue. That's our oxygen. And then you have 2 hydrogens. And I'm going to make these hydrogens a little...
That red just doesn't show up very well when you use green.
I think if I color it in, you can see it.
Okay.
So here are our hydrogens. So this is water, H2O. And rubbing alcohol, also called isopropyl alcohol, is very different. It also has an oxygen, but that oxygen is bound to just 1 hydrogen. So there's our oxygen in rubbing alcohol, and it's bound to 1 little hydrogen here. And then it's bound to 3 carbons. So I'm going to draw our carbons here. We have 1, 2, 3. And those 3 carbons, of course, are all going to have little hydrogens on them because carbon always likes to make 4 bonds. I'm going to draw my little hydrogens here, and then we get 3 more little hydrogens over here. So that is rubbing alcohol. We have an oxygen, just like we do in water, but then instead of having 2 hydrogens, we've got these 3 big carbons down here. And tomorrow we will go into more detail about why you see the crazy mixtures that you get when you drop just a little bit of rubbing alcohol into water. And if it's thin and on a plate and you drop a little bit in, it will actually create this blank space in the middle where all the water gets pushed out and you have sort of this empty circle for a while. And again, I want you guys to do a little research yourself, see if you can figure out why that happens. And then tomorrow we'll explain a little bit more about the chemistry of these 2 things, and we'll have the answer for you. But quick answer to why does rubbing alcohol smell? And it is these carbons right here. This molecule is small enough that it's easy for it to go up into the air and turn into a gas. And that the word for that we have in science is volatile. It's volatile, VOLITILE. And since it's volatile and it will go up and become a gas, it's easy for the chemicals in our nose, our scent receptors, to bind to it and detect it. And it has a very distinctive smell. Now we'll come over to this side.
So earlier, somebody was asking, what's the difference between silicon and silicone?
That is a great question. I would have to look it up. We'll try and make a note to add that. I'll ask Science Mom Emily to add that to our list, and maybe we can answer that tomorrow. Silicone versus silicon. I'm not sure off the top of my head.
How do rocks form?
How do rocks form? That's a great question. It depends on the type of rock, but for the most part, excuse me, I'm going to get a drink. You answer that question. Do your best.
Yeah. So these aliens landed at this one. No. Okay. So it does depend on the type of rock. So you've got metamorphic rock, which is formed just by pressure over a long time. It's the hardest type of rock. So thinking of like diamonds, for example, there be an example. But then you've got igneous rock, which is formed from lava formations and from lava cooling. And then you've got sedimentary rock, which is
tiny little grains of sand all smushed together really hard.
Smush the sand together and long enough and hard enough, and it's become rock. So take a long time for it to become more metamorphic rock.
Someone asked, can you use a paper plate for the, when you put the dry erase marker? You can, but it works better with a hard plate.
It doesn't sink in at all? It just stays on the surface?
How does rubbing alcohol react against the Sharpie and the Expo marker? I think we'll answer that more tomorrow. We'll answer that more tomorrow. Good question. This is a good question. Is an atom smaller or a germ smaller? Why can't you see them with eyes, but you can with a microscope? And so is an atom smaller or a germ smaller? An atom is definitely smaller than a germ. And the scale that you have is kind of mind-blowing just with how small atoms are. Atoms are incredibly small, even with our most powerful microscopes. It is really difficult to get any visual of an atom because they're just too small. Germs, depending on the germ, they're a lot larger than atoms, but they can vary in size a lot too. Something like a virus, like the flu virus, is really, really small. And then if you go up to a bacteria, you get quite a bit bigger. Bacteria tend to be larger. And then if you go up to something like Giardia, which is actually more closely related to other animals than it is to bacteria, it's a more complex type of single-celled animal, it's quite a bit bigger. It all depends on the type of germ you're talking about. Can rock melt back to lava? I saw that question. It definitely can. If you get it hot enough, it'll turn into lava.
That's scary hot.
This is a good question. Why does a year consist of 365 days and a day of 24 hours? Great question.
Ooh, I know. So the day is 24 hours because the day is just a measurement of how long it takes
the Earth to spin around.
So why did we cut that into 24 equal pieces? That one's actually a little bit harder. So if you go back to like the Babylonian calendar, they used base 60, and originally each month was assigned exactly 30 days, and then there were a few extra days tossed in there to try to make up for it. So 60 minutes in an hour. Why the number 24? How did they slice it that way? Yeah, that I'm a little less sure of. And then the year, it has 365 days in it. That's you're literally just counting the number of times that the Earth revolves as it goes around the sun. So that count was kind of forced upon us.
But that count is not quite accurate. So if you have 365 days and then you don't do anything to change that, it doesn't take very many years before your calendar starts to be off, where, January does not line up with the shortest day of the year anymore, or December. Yep. And so that's why we have leap year. And this year is a leap year.
That's right. We got an extra day because it's really like 365 and a quarter.
Ooh,
approximately.
I want this question. So we will be getting to astronomy in another week, but how are stars formed is a great question. How are stars formed? And it really has to do with gases that you have in space. So space is mostly empty space, but there is a lot of hydrogen and helium. Those two elements are the most abundant elements in the universe. And when they condense and start to gather together, if you get enough of them, the gravity, just the force of things being attracted to each other, will condense down and form stars. That's kind of the short answer. Ooh, is there anything smaller than an atom? Yes, and we will be talking more about that later this week. But there are subatomic particles like electrons, protons, and neutrons, and then there are things even smaller than those.
But they say the atoms are the smallest because they're the smallest.
They're the smallest
of a given type.
Yeah, so atoms are the smallest part of something that still acts like that something. So if you have an atom of water, it still is going to have the properties of water. Well,
no, that was a molecule.
Molecule. You're right. So if you have an atom of oxygen, it's still oxygen. But if you go down to a proton is not going to resemble oxygen at all. It has different properties.
So somebody asked, what are the ending answers for addition, subtraction, multiplication, and division called? So the final result. So for addition, we call it the sum. For subtraction, it's the difference. For multiplication, it's a product. And for division, it's a quotient.
Very nice. I would not have remembered that division was called a quotient because I have not used that in a long time. What happens if you put dry ice on a hot surface? It will sublime faster. It all depends on how hot the surface is. But just like a puddle of water will evaporate on a hot day, dry ice, if it's warmer, will sublime and turn into a gas faster.
Someone was asking, how does salt dissolve in water?
How does salt dissolve in water? That's a great question. We'll be talking about that more this week, actually, when we talk about bonding and chemical reactions. But the short answer is that salt is an ionic bond. So you have the positively charged sodium, the negatively charged chlorine. Did I say that backwards? I got it. And when you put that into water, then those parts that are negative and positive, they go apart because they're surrounded by their water buddies and they're happy being surrounded by water.
Can you see oxygen in a microscope?
I don't think so.
Gases are hard to observe, but do you actually see just
the only pictures that I have seen of atoms was of a gold plate that was really thin, and you have to use a really special microscope to be able to see an atom, and they've got to be spaced really regularly, and really they just look like little kind of fuzzy dots that are spaced regularly. It's very, very difficult to see an atom because they are so small.
What is oxygen made of?
Oxygen is made of neutrons, protons, and electrons, just like every other atom is. And we'll talk more. Oh, you know what I realized I forgot to share with you guys? I made a comic. And we'll talk more about this comic tomorrow. But I'm going to pull that up right now because, in my opinion, it's a fun little comic and answers some of these questions. So this comic here there's a little cafe, and it's the Elemental Cafe where you can order an element. So how do you order your element? First, you choose the number of protons. And again, we'll be talking about this more tomorrow. And the number of protons tells you what element you're getting. You can change the number of neutrons to make it an isotope, or you can adjust the number of electrons to make it an ion. But you'll see here, numbers above 90 are not served because those tend to be radioactive and dangerous, and there's limited availability with our ions. So this little star comes up and says, can I have number 2, please? And 2 protons gives us helium. The other star says helium, sure. Do you want 2 neutrons or 3? And he says, I don't know. 2 neutrons will be $2, 3 will be 200. 2 neutrons, please. Please give me 2.
Yeah. So what that says that 2 neutrons is the default for helium?
Yes, so 2 neutrons, 2 protons together in the nucleus gives you the nucleus of helium, and you have 2 electrons around the outside. And again, today was just a really quick introduction to chemistry. We'll be talking more about elements and chemical reactions and things tomorrow. But that little comic there that I had made previously for something, I thought it was a good way to just sort of talk about neutrons, protons, and electrons.
So please tell about quantum numbers.
Ooh, quantum numbers and what type of matter are electrons and protons? These are great questions. And the best answer we can give now, because we're getting short on time, is keep watching this week. You will find out a lot more about these subjects in the next few lessons.
I don't want to spoil it too much, but you're asking the right questions.
Oh, and someone asked, do I know Hindi? I do not know Hindi, although I did learn a few phrases one time. I don't think I remember them. I don't think I remember them right now.
All right, so the usual question, can you eat dry ice?
No, don't eat dry ice.
No.
Really bad idea. Really bad idea. You would hurt your mouth a lot. And then one last question that was put on our Facebook page. If you put if you put Mentos into ice cubes, will that make soda fizz up once you put those ice cubes into a soda glass? And the answer is no. If you take Mentos and you get them wet, then you get rid of that rough surface, which is what you need for the reaction to happen. So if you take some Mentos, put them in soda, and they make the soda fountain, and then you take those same Mentos out and put them in a new bottle of soda, they won't work at all because they got wet, and that dissolved that rough layer off of the Mentos candy. Someone else asked, will Mentos gum work? And it will. We had someone who, that's all the Mentos that they had, and they tried it, and they said it worked. So
nice.
Yeah. And then the last thing that I want to share before we go is a quick note about if you want to submit your art or your images. Science Mom Krista and I are working on getting a better system set up in Facebook where you can submit your images, and then you can also comment and look at the other artwork that has been shared. And we would like to ask your help with this because there are so many submissions that there are too many for us to look at and just comment individually if we want to be able to get ready for the next lesson. So if you guys can be a community and help us to give feedback on the other artwork and help us, by liking and commenting on them to sort of find the ones that we should feature, that will help a lot.
And then it's fun to go through and look at them. You kids are awesome.
Yes. Oh, we have loved seeing the artwork. And then the last thing that I want to say too is thank you so much to our patrons who have joined us on Patreon this week, because we really want to keep QuaranTIME completely free and the handout's free for everybody, because we know this is kind of a crazy time that we're in right now. And the support of our patrons is helping us to do that. So thank you so much to everyone who has joined us in Patreon the past few days. Do you have anything else you want to add about your math challenge before we wrap up?
No, I'm just curious. How far did this hippo walk? It was 8 miles the first day, or kilometers, 8 kilometers, then 4, then 2, then 1, then 1/2, and it just keeps going forever.
How far does the hippo walk?
Yep.
We'll find out tomorrow. And we're having a couple people saying, no, don't end it. And other people saying, bye. I will end with just kind of my favorite thought that I like to leave with you each time. And that is that you are a human being and we are part of humanity. We're part of a human family. And that is an amazing thing. I'm so glad that we have the technology to be able to talk to you right now all across the world. It's amazing to me that we are talking to viewers who are all over the United States, in Canada. We've heard from people in Costa Rica and South America and Italy, and I'm so happy that we're able to share science and math with you. We want this to be something that is super helpful to you. We really welcome your feedback, and if you have any requests, check our Facebook page. You can email us or post on Instagram with questions you have, and we'll try to incorporate as many as we can. And we'll see you tomorrow with answers to that math question and more chemistry.
Take care.